Hello everyone, welcome to Abhi online classes. Today we'll discuss some problems in limits and continuity. First problem, if f of x is equal to 1 minus cos 2x by x square when x is not equal to 0 and f of 0 equal to k is, this function is continuous at x equal to 0. Now we have to find out the value of k. In the problem, it is given f is continuous at x equal to 0. Since f is continuous at x equal to 0, by definition, limit x tends to 0 f of x is equal to f of 0. We use this definition. Limit x tends to 0, that means x is tending to 0 means x is not equal to 0. When x is not equal to 0, f of x is 1 minus cos 2x by x square is equal to f of 0, it is given k. Limit x tends to 0. 1 minus cos 2x means in trigonometry 2 sin square x by x square equal to k. We bring this constant term outside this limit. 2 into limit x tends to 0 sin x by x whole square equal to k, and this value is 1. Limit x tends to 0 sin x by x is 1. 2 into 1 square is equal to k. Therefore k is equal to 2. Therefore answer of the value of k is 2. Now we'll see second problem. If f of x is equal to 7x minus tan x by x when x is not equal to 0 and f of x is equal to k when x equal to 0, this function is continuous at x equal to 0 and we have to find out the value of k. In this problem also it is given f is continuous. Since f is continuous at x equal to 0, therefore by definition limit x tends to 0 f of x equal to f of 0. Limit x tends to 0 f of x is, when x not equal to 0, f of x is 7x minus tan x by x is equal to, and it is given when x equal to 0 f of 0 equal to k. We have to put the value of x equal to 0 in this. Now f of 0 equal to k. Now we split the limit. Limit x tends to 0 7x by x minus limit x tends to 0 tan x by x. Like this we split the limit into two limits is equal to k. Cancel x. Limit of constant is constant. Limit x tends to 0 tan x by x value is 1. So 7 minus 1 equal to k. Therefore k is equal to 6. So once again, given this function is a continuous at x equal to 0. Since f is continuous at x equal to 0, we use the definition limit x tends to 0 f of x is equal to f of 0. X is tending to 0 means x is not equal to 0. When x is not equal to 0, f of x is 7x minus tan x by x. Limit x tends to 0, 7x minus tan x by x is equal to f of 0 is, we put x is equal to 0 here, f of 0 gives is k. Therefore f of 0 is equal to k. Now splitting this limit into two limits. Limit x tends to 0 7x by x minus limit x tends to 0 tan x by x. Limit of constant is constant, cancel x. Next limit x tends to 0 tan x by x value is 1. Therefore 7 minus 1 equal to 6. Therefore k value is 6. Third problem is, if f of x is equal to 2x plus 1 when x is less than or equal to 1 and f of x is equal to ax square plus 1 when x is greater than 1. Given this function is continuous at x is equal to 1. We have to find out the value of a. In this problem also it is given f is continuous. Since f is continuous at x is equal to 1, by definition limit extends to 1 plus f of x equal to limit extends to 1 minus f of x equal to f of 1. Here we are using the second definition of continuity. In the previous videos we have discussed both the definitions, two definitions on continuity. For this problem we are using definition 2. How it is, if x is less than 1 means it is in the negative neighborhood of 1, therefore it is 1 minus. When x is greater than 1, it is 1 plus, it is in the positive neighborhood of 1. It is in the negative neighborhood of 1 and this is the positive neighborhood of 1. So here limit extends to 1 plus. When x is tending to 1 plus, x is in the positive neighborhood of 1, we have to take f of x as ax square plus 1. When x is tending to 1 minus, f of x is 2x plus 1. F of 1 means here x is equal to 1. We put x is equal to 1 here. F of 1 is equal to 2 into 1 plus 1. For x is equal to 1, we replace x by 1. F of 1 is equal to 2 into 1 plus 1. Now we change this limit into h. Limit h tends to 0. A into, we write in place of x 1 plus h. Replace x by 1 plus h. Here replace x by 1 minus h. In this x we are replacing 1 minus h. Here 1 plus h. Plus 1 equal to 2 into 1 2, 2 plus 1 3. Now on substituting h equal to 0, a into 1 plus 0 whole square plus 1 equal to 2 into 1 minus 0 plus 1 equal to 3. 1 square is 1, 1 into a plus 1 is equal to 2 plus 1, 3 equal to 3. Now we equate these two terms. A plus 1 equal to 3 implies a is equal to 2. Therefore the value of a is 2. In the problem itself it is given f is continuous. But in this problem we are using the second definition, that is limit extends to 1 plus f of x is equal to limit extends to 1 minus f of x is equal to f of 1. Previously we have seen the first two problems in definition 1 and now this problem it is under definition 2. Limit extends to 1 plus, here 1 plus f in the positive neighborhood of 1, f of x is ax square plus 1. In the negative neighborhood of 1, f of x is 2x plus 1, and put x is equal to 1 directly here. F of 1 is 2 into 1 plus 1, that gives 3. Here replacing x by 1 plus h and now replace x by 1 minus h. So we got a plus 1 equal to 3 equal to 3. On equating these two terms, a plus 1 is equal to 3 gives a plus a is equal to 2, 3 minus 2. We shall see fourth question. Show that the function f of x equal to mod x plus mod of x minus 1 is continuous at x equal to 0 and x equal to 1. We have to show this function is continuous at both the points x equal to 0 and x equal to 1. Now first we see definition of mod x. Definition of mod x is plus x when x is greater than 0. Mod x equal to minus x when x is less than 0. Mod x equal to 0 when x equal to 0. X is greater than 0 means it is 0 plus. X is less than 0 means 0 minus. So when x is in the positive neighborhood of 0, we should take mod x as plus x. When x is in the negative neighborhood of 0, we should write mod x as minus x. When x equal to 0, mod x is also equal to 0. In the same way, mod of x minus 1. Mod of x minus 1 equal to x minus 1 when x is greater than 1. Mod of x minus 1 equal to 1 minus x when x is less than 1, and it is equal to 0 when x equal to 1. F of x is equal to mod x plus mod of x minus 1. Suppose it is 1 and this is 0. We are splitting mod x as minus x when x is less than 0 and mod x as plus x when x is greater than 0. This is 0 plus, this is 0 minus. So we write mod x as minus x when x is tending to 0 minus. When x is in 0 plus, positive neighborhood of 0, we should write mod x as plus x. In the same way, when x is greater than 1, we write mod of x minus 1 as x minus 1. When x is in the negative neighborhood of 1, we write mod of x minus 1 as 1 minus x. We are splitting mod x like this and mod of x minus 1 like this. Now we prepare f of x. When x is less than 0, when x is less than 0, mod x is equal to minus x plus. When x is less than 0, these are all less than 0. All these x's are also less than 1. So we write mod of x minus 1 as 1 minus x. So mod x as minus x, mod of x minus 1 as 1 minus x. Suppose we take x greater than 1. We see this. When all the x's are greater than 1, means mod of x minus 1 is equal to x minus 1. All these x's are also greater than 0. That is, they are in 0 plus. Then mod x, we write this as plus x. Now when x values are lying in between 0 and 1 and also equal to 0 and equal to 1, when x's are lying in between these 2 points in this interval, mod x is equal to plus x and mod of x minus 1 equal to 1 minus x. Therefore, f of x is equal to 1 minus x minus 2x when x less than 0. Plus x and minus x cancel, so we got 1 when 0 less than x less than or equal to 1. X plus x 2x, 2x minus 1 when x is greater than 1. Now I repeat, f of x is equal to mod x plus mod of x minus 1. We write mod x as plus x when x tends to 0 plus. Mod x is equal to minus x when x is in 0 minus. Mod of x minus 1 as x minus 1 when x is in 1 plus, positive neighborhood of 1. Mod of x minus 1 as 1 minus x when x is in 1 minus. We should add these two mods. So we have to prepare now for 3 cases. First we take x less than 0. That means x is in the negative neighborhood of 0. All these x's are less than 0. When x is less than 0, we should write mod x as minus x. So mod x already I have written. These x's are also less than 1. That means they are in the 1 minus, negative neighborhood of 1. All these are less than 0 as well as they are less than 1. So therefore they are in 1 minus. So we should write mod of x minus 1 as 1 minus x. So on adding these two we got 1 minus 2x. That is when x is less than 0. When x is in between 0 and 1, when x is in between 0 and 1, mod x is equal to x, mod of x minus 1 equal to 1 minus x. We should add these two terms. So on adding these two terms, plus and minus x cancel, so we got 1. When x is greater than 1, third case is when x is greater than 1. All these x's are greater than 1. These are all greater than 1. These are all greater than 0 also. That means they are in the positive neighborhood of 0. They are in the positive neighborhood of 1. So in the positive neighborhood of 0, mod x is equal to plus x. In the positive neighborhood of 1, mod x minus 1 is equal to x minus 1. So we should add x and x minus 1. On adding these two, 2x minus 1 we got. So that is how we have prepared f of x. Now we discuss whether f is continuous at x equal to 0 or not. We'll see. X less than 0 means x less than 0 means it is in negative neighborhood of 0, that is 0 minus. Here 4 cases are there. X equal to 0, x less than 0, x greater than 0, that means 0 plus, x less than 1, that means 1 minus, x equal to 1. 4 cases. Once again I repeat, x is equal to 0, x is greater than 0, x is less than 1, x is equal to 1. Greater than 0 means 0 plus, less than 1 means 1 minus. Here x is greater than 1, that means 1 plus. At 0 we first check f is continuous or not. First we take, according to the definition 2 we solve this problem. Because we have 0 minus and 0 plus and 0, we use the second definition. First we take left-handed limit. Limit x tends to 0 minus f of x. Limit x tends to 0 minus, when x is in the 0 minus, f of x is equal to 1 minus 2x. Now we convert this into h. Limit h tends to 0, 1 minus 2 into, we write in place of x 0 minus h. Put h equal to 0. So we got 1. Left-handed limit 1. Now right-handed limit we see. Limit x tends to 0 plus f of x. Limit x tends to 0 plus. When x is in 0 plus, f of x is equal to 1. Limit of constant is constant. Now we'll see third one, f of 0. When x equal to 0, also f of x is equal to 1. Therefore, left-handed limit equal to right-handed limit equal to f of 0. All are 1, 1, 1. Therefore, f is continuous at x equal to 0. By definition 2 we have checked, because we have 0 plus, 0 minus and equal to 0. So that is why we have taken definition 2. Now we check at x equal to 1 f is continuous or not. First, left-handed limit. Limit x tends to 1 minus f of x. Limit x tends to 1 minus here. F of x is 1. Limit of constant is constant. Now we should take right-handed limit. Limit x tends to 1 plus f of x. Limit x tends to 1 plus here. F of x is 2x minus 1. We convert this limit into h. Limit h tends to 0. 2 into, in place of x we write 1 plus h. Put h is equal to 0. So 2 minus 1, 1. Next, last one, f of 1 we see. At x equal to 1, f of x equal to 1. So left-handed limit 1, right-handed limit 1, f of 1 equal to 1. Therefore, left-handed limit of f of x at equal to 1, right-handed limit of f of x at x equal to 1 equal to f of 1. All these three are equal. Therefore, f is continuous at x equal to 1. Therefore, this function is continuous at both x equal to 0 and x equal to 1. Therefore, this function f of x is equal to mod x plus mod of x minus 1 is continuous at both x equal to 0 and x equal to 1. Similarly, this function, same function, is not differentiable at x equal to 0 and x equal to 1. That we'll see in the differentiability chapter. Now, running topic is continuous, so that is why we have tested only continuity. So, definitely this function is continuous at x equal to 0 and x equal to 1. Hope you understood this class. We can work out similar problems in the textbook or material. Hope you understood. Thank you.